Hello, it's Keith here, and this is the first of the so-called ChibiTracks tutorials. Now, what we're going to do in this series is we're going to look at my ChibiTracks music player. This is a multi-platform music player which is designed to play music created with my so-called ChibiTracker PRO. Now, the ChibiTracker PRO you can see here, and here we've got a copy of the Chibi Acma's theme song. So you can hear that there, and you can see the format of the music here. And the ChibiTracker PRO, it's mimicked in a lot of ways off Arcos Tracker, which is the Amstrad CPC tracker, which is very good. I'm a big fan of it. However, I needed something that I could report to other systems reasonably easily, and that music software was too complex for me. So I've written my own music player, which is a little bit more simple and easier to port to other systems. Now, this is the tracker, but there is a player which is multi-platform and multi-CPU. Now, there is a bit of an unholy trinity with this. Basically, ChibiTracker PRO is the Windows-based music player, which music composer, you just saw. ChibiTracks is the software which runs on each CPU. So this is the Z80 version of ChibiTracks running on the Amstrad CPC. And then what there is there's a platform-specific sound driver called Chibi Sound Pro, which is the part that actually converts the required channel settings into what is required for that hardware to play the sounds. And how that happens is entirely dependent on the system, because different systems have different capabilities. Now, ChibiTracks is designed for a minimum of 3 channels. It's really only programmed for 3 at the moment, but what the Chibi Sound Pro driver will have to do is, if the system's only got 1 channel, it will have to somehow figure that out. You know, will it play the loudest channel? Will it only play channel 1? Well, that's up to that particular driver, but it has to prioritize the channels so that the channel 0 is the most important, channel 1 and channel 2 are less important, so it can decide what to do with those as it requires. Now, so that we can get started into learning how ChibiTracks ChibiTracker PRO work, what we're going to do today is we're going to look at the ASM files which can be compiled and played with the ChibiTracks software. Now, here is an ASM file. If we just get my assembly details out of the way for a moment here. So this is an ASM file which is compilable with VASM into a binary song which can be played with the ChibiTracks player on the Z80 systems. Now, the rather weird thing that I decided to do though is this is actually the main format for a Chibi Sound song when you're actually writing it within the tracker itself. So when you use the load and save options here, these are the main options here. These are actually saving that ASM file. So the ASM file actually contains the binary data that is required to play on the end systems, but also the extra information for the music tracking software to work in itself. And the reason for this is that the music tracker itself is actually working is in a lot of ways as a binary player. It has a simulation of the Chibi Sound Pro driver built into it, and it is processing the data in the same format as the binary files themselves. So the view here is being built up from the binary data held within the structures within the software. Now, the reason I did that is my sort of thinking was, well, if I can't make a C# application cope with the same binary format as assembly is having to cope with, well, that pretty much suggests something quite bad about my C# skills, which might be justified, to be fair, but I did feel that it was the smart way to make the high-level language do the same as the low-level language. Now, originally I'd planned to write ChibiTracker PRO as an assembly program, but my patrons didn't want me to do that, so I had to do it in C#, which was a bit of a shame. Now, at this point, I am going to have to shill my Patreon a little bit. If you want to see this kind of work done, please consider backing me on Patreon. The reason I'm saying this is because when I'm writing C# applications, I'm not gaining anything for it. I'm just throwing hundreds and hundreds of hours into writing an application that honestly I didn't want to write. Now, at the moment, my channel is basically entirely funded by the sales of my books. I make $30 a month or less off YouTube memberships and adverts, so that's simply not a way that I can fund this channel. So if you want to see work like this done, please back me on Patreon, because I can't make a YouTube channel full of free content via book sales and also write C# applications. Something's going to give, because at the end of the day I'm doing this in my spare time, I've got a day job as well, so I just simply can't take on everything for free. I can't do it. So anyway, that said, let's go over today. Let's take a look at the ASM file, and what we're going to do is we're going to discuss the sections of the ASM file, and I'm going to reference it back to ChibiTracker PRO as appropriate, and then hopefully it will all start to make sense why ChibiTracker PRO works in the way it works, why the assembly file is structured, how it works, and what everything means. And then what we're going to do over later lessons is we're going to break down the actual player on the Z80 systems and on the other systems as well. It's the same basic functions, but just reorganized for the different CPUs, and we'll learn how everything works. So let's go over to our assembly file and let's take a look. So this is the file we're going to be looking at today. Okay, let's take a look. So at the start of it, you'll notice there's a lot of comment lines. Well, what are these? Well, it probably won't surprise you too much, but as I said, ChibiTracker PRO is actually using the exact same source file as its own data file. And so there's a lot of things that aren't going to be contained within binary data within the destination file that the tracker itself actually needs. For example, maybe a song name would be useful, maybe a number of channels for future proofing, maybe things like some settings for the user interface, like the currently selected octave. That thing down there is being stored in this line here of this comment. These are comments from the point of view of the compiled assembly file, but they aren't comments from the point of view of this being loaded into ChibiTracker PRO. And so you can see there's all kinds of things relating to MIDI ports and lots of stuff in there that, you know, might seem a bit unnecessary. But as I say, these are basically very important when it comes to ChibiTracker PRO processing this file and reading it in as something that can be edited again. So in theory, you can edit this file with a text editor and reload it into ChibiTracker PRO. But if you do anything that the ChibiTracker PRO can't cope with, you're going to get a crash probably. So not advised, but is possible. As I say, the main reason for doing this was that it seemed far more sensible for me to have a text file as my data file for readability and for tweaking, if necessary, debugging as well for that matter. But as I say, creating an actual assembly file that could be compiled with an assembler seemed to me to be the best of all worlds, so that's what I did. But as I say, lots of things needed outside of what is binary data in the final file. So you can see here we're defining the start of the header section with CBT head here, and CBT end defining the end of the header section. And then what we've got here is CBT sequence, and here's the end of a sequence. Well, what does the header actually contain? Well, the header contains a variety of things. Firstly, there is a number of channels, which is 3, and it should always be 3 in the current version because the tracker has currently really only been optimized for 3 channels, and I might extend it to more later, but at the moment it's a fixed value. There is a repeat point. Now this is when we get to the end of the song. What pattern do we jump back to? Do we jump back to the very first pattern at 0, or do we skip parts so that we have an introduction that's only played once and then we loop to another pattern every other time? So 0 is the very start. 1 would skip the first line of the pattern sequence, and so on. Song speed, this is set to 5. Now this is basically a multiplier for the delays between each of the lines of the pattern. So this means that there will be 5 times the delay that is specified within the patterns themselves. It's possible to multiply out this, and this allows for an optimization. There are a couple of options that you can enable with ChibiTracks that will increase the functionality at the cost of size and speed. Now, allow speed change will allow that speed option to function. So that song speed of 5 will function here. And we'll see later on, for example, this 1 here, dB1 there, that line will last just 1 tick. But because we've got a speed of 5, it would actually last 5 ticks. But we can multiply this out in settings. If we select pre-multiply song speed, then this speed would effectively be 1. It would not be used. And we would then specify a speed of 5 for that dB1 and a speed of 10 for that dB2 there. That first byte on those lines is the length in ticks of that line, how long that line is processed before the next line is processed. Basically, it's a delay, if you will, before the next line. And if we enable that pre-multiply, we can disable this allow speed change option here, and that will make the player a little bit smaller and a little bit faster, just very slightly, but that is an option for us. So in this case, I've not done that. Allowing the song speed option does allow us to reconfigure the speed depending on the end system. If there are issues where that system is slower or faster and we need to change the speed, you know, maybe our system has a different refresh rate on its VBlank and things, you know. But as I say, that is an option. We then have a series of addresses. Now the first one is the address that the song is going to be loaded into in memory. Now, because this is an assembly file, it just points to my song. But if we'd exported this as a binary file, we can specify a memory address to load to. So, for example, if we were going to load the binary file into our resulting Z80 program at memory address 8000, we would put the value 8000 there, and then that would be pre-coded into all of the offsets within the file itself. Now, this is another thing that ChibiTracks has an option for. If we enable this allow relocation option, it really doesn't matter what address is specified as the compiled address in the file, it will still play fine. However, doing so means that every time we're using an address in the file, we are having to recalculate an offset. And if we don't have to do that, we could disable this line. But so that the offsets can be calculated if required, we have the address that the song was compiled to be loaded to at this position here. What we then have is a series of addresses to various important pieces of data within the file itself. The pattern list, now this is a series of pointers to the patterns. It appears at the end of the file. So these are the addresses of the numbered patterns within the file itself. We also have an instrument list, which is the address of the instruments within the file. So if we're asked to play instrument 1, well, where is the data for instrument 1? Well, we need to look at this index within this pointer array here, and that would get us the pointer to instrument 1. Now, these are of course all labels in this example because it's an ASM file, but if this was a binary file, this data would all be contained in the binary, and it would of course be fixed addresses, and they would all be calculated relative to that song load address, which, as I say, is why if you do not allow relocatable, that song load address becomes very important. But I am tending to always use allow relocation because the thing that I wanted to achieve with this software is portability. I want to compile for the Amstrad CPC my binary file for my song. I then want to play it on the ZX Spectrum, the Amstrad CPC, the MSX, the Nintendo NES, which is of course a 6502 system. I also want to maybe play it on the PC Engine 6502, and I want to maybe play it on the Neo Geo, which is a 68000 system, or a Genesis 68000 system. And these are very different systems, different memory maps, and different engine with the 68000 systems. And so the software has been configured to allow me to do that, and allowing relocation is something that makes all of that far easier and far less hassle. I don't want to export my song file 20 times for the 20 different systems because the memory address map makes different load addresses convenient. I don't want to do that, so I'm not going to. Finally, then, in the header we have the addresses to the sequences, and you can see the sequences here, and these are a series of numbers here ending in 255. Well, what are these? Well, these are the playing patterns. Now, here is our song as a sequence, and you can see that there is a column here for each of the channels, and the numbers here are the patterns that are going to be played by that channel. So channel 0 here is playing sequence 1, channel 1 is playing sequence 1, and channel 2 is playing sequence 12 here. And if we look over here, you can see those sequences, and those first two are completely empty, and the third one has actually got some data in it. And you can see that this data here is represented here. So that 1 there is pattern 1, that 1 there is pattern 1, and that 12 there is pattern 12, and you can see pattern 12 is represented there. And the end of the sequences is always ending in 255, which means end, and it will jump back to whatever the repeat point was. Now, one thing that it's important to notice at this point is these should all be the same length. If you don't make them the same length, you're kind of at the mercy of what the player does. I think the Windows player will actually repeat all of the channels simultaneously, but the assembly player will actually, the channels will end up out of sync, because I don't think it forces a reload of all the channels automatically. I can't quite remember off the top of my head, but yeah, as I say, these should really be the same length, but if you're using my tracker, they will, because the tracker creates valid files usually. That's the plan anyway. So each of these relates to a pattern, and the pattern numbers will be converted into a memory address from the lookup table at the end of the file, which you can see here. So how do the patterns work? And the next question is, and it's an interesting question, is how do the instruments work? Well, here are some patterns here. You can see each line of these patterns here is basically one line of this file here. So you can see there's a line there that says 624 1C 240, and then there's a blank line, and then there's another line. The blank lines are not represented. The way the blank lines are represented in the file is by a larger delay. So for example, you can see here that first byte is always a 1, and that's the delay until the next line. So these are all consecutive lines. So this is pattern 2. Let's take a look at pattern 2. So here is pattern 2 in memory, and you can see that there's a byte 24 at the start. Now what this means is that after this line there are 24 unused lines. Now this line here is basically setting the volume to 0. 0E must be the volume command. I can't remember off the top of the head, but it clearly is. And 00 is the new volume setting. Then the next 00 is actually the end of the line. You'll notice every line ends with 00. That's an end of line marker. So 0E00 is setting the volume to 0, which you can see there. We then got a grand total of 24 lines doing nothing here. And that is why we've got a delay of 24 after this line. And then the following lines all have a delay of 1, and the reason for that is the following lines all have no space in between them. Now this is basically a convenience for the player, the music player within Z80. The music player will load in the delay, load in the sequence of commands, process the commands, and then set the delay until it needs to basically wake up and reload in another line and process the new actions. So that's why it's in this format, and it was a bit of a pain for the tracking software to do the same thing, because as I say, the tracker software actually has the data structures in memory in the same format, and so when you're deleting a line it's having to work out if there's a delay until the next line and so on and so forth. But as I say, I wanted to make the tracker do the same job as the assembler would do in C#, so that's what I did. So yeah, this is basically the format. The first byte is always the delay. The following bytes are always the sequence of commands. The format of those commands varies, and we will see those when we actually look at the tracker's ASM source as well later on. So we're not going to go into that in detail now. And then the final byte on each line is always a 00. So a command of 00, if you will, is an end of line. And then you can see here, this 10 is a special command. That basically means end of pattern. You will notice every single pattern ends with a 10, and that's basically telling the software that has ended. Now that is the patterns, and that is the format of the patterns. Well, what about the format of the instruments? Well, are you ready for a surprise? The format of the instruments is exactly the same as the format of the patterns. Because it's the same code doing both. So anything pretty much that a pattern can do, an instrument can do, and anything that an instrument can do, a pattern can do. So a pattern can define which note, C#, for example, to play, but so can an instrument. If you want your drum to always play the same note, you can program it to do that. If you want your instrument to set the volume, you can do that. If you want to set the noise on and off at the pattern level, you can do that, because it's the same code doing both. The only time that's not going to work very well is if you do things like have an instrument that triggers an instrument. That could cause unpredictable effects. I think it would work, but it's not something I'm really intending you to do. And if you had the end of pattern command within an instrument code, well, I have no idea what would happen, but I've never tried it. But again, the code could do it, because the playing of an instrument is the same code processing the command sequence as the playing of a pattern file. The two are the exact same code. It's not that they're programmed the same, it's the same piece of code doing both jobs. And I've found no faults. I've had no problem doing that. It seemed to me to be the logical way of doing it for all of the functionality everywhere, and it makes the program smaller, I think. So I say that's what I've decided to do. So again, the instrument sequence is exactly the same. So we've got a byte at the start, which is the length of the line, the delay until the next line rather. We've then got a sequence of bytes, which are commands, and we've got a 0 at the end, which is the end of line command. An instrument will end when the line has a delay of 0. Now that's slightly different in a way from the pattern, which will always end with a 10, because the 10 instructs the player to read in the next pattern in the sequence. So you never get to a 0 line within a pattern, because you're always instructing the player to start playing something else instead. In theory, I suppose you could have a line 0, but it doesn't make sense in that case. Now the first instrument here is the silent instrument, you can see here. But let's take a look at the kick instrument, and let's see what that looks like. So here is the kick instrument. You can see its name here in this comment line here, and we've got a sequence of lines here. And if we have a look at the editor, we'll see what's going on. And this is somewhere that the tracker is quite crude. It's partially because I simply don't care, to be honest. I was quite happy to code all of this in assembly. I only wrote the player because, as I say, my patrons wanted it. So it's quite crude, but that is for convenience of creating binary files that the player can work, the Z80 based player can work with. So each line of this instrument is basically a series of commands in the sequence. The very first byte there, that 2, is the delay until the next line. You can see that 210 there, and you've got that 210 there. The value in brackets is the number of bytes in that line's commands until the next line, and that's so we can calculate loops, because at the moment you have to calculate them in bytes, unfortunately, but as I say, it's a very limited player at the moment. And then you've got a series of instructions here. That now note 20 there, you will see that there. That is this OD14, I believe. That OD is a note selection, and 14 is 20 in hexadecimal. So that's what that is. OEFF here, I think that is setting the volume to 255. FF is called 255, and I guess 0E is the volume. Again, I can't remember these off the top of my head. D0, I think, is setting the pitch, so we're changing the pitch bend to 0 here. And then C1, now the C top nibble is selecting the noise, and C0 would turn the noise off, but C1 will turn the noise on. So what we're doing here is we are enabling the noise, setting the volume to 255, the note to 20, resetting the pitch, and we've got a delay of 2 ticks until the next line. And the next line is setting the noise off here. Now, if we wanted to do something else, like maybe we wanted a pitch bend for some reason, we could do that. We could put in a value of 10 here. And then if we go to update here, you can see the line has now added a pitch shift of 10 and the noise is still being turned off there. So we've now changed that line and an extra byte has been added because that 2 in brackets has been changed to a 3. And then if we re-exported this file, the byte script for the instrument 2 would now have an extra command in that second line, which would be the changing of the pitch. So that would be probably D0A or something like that, maybe. I can't remember off the top of my head. But as I say, basically, these are scripts with each line being a set of commands in the process. Now, say, with regards to the instruments, each line in this list here is literally a representation of this line here. It's literally a byte converter that converts the bytes to text. It's showing that to the screen. The editor, each line here is one of the lines with data in this list here. The lines with just dots, the empty lines, they aren't represented, and you will see that when there is an empty line, you will see the delay is higher than 1. A delay of 1 means that there is data on the next line. A delay of 2 means the next line is blank, but the line after has data, and so on. So there we go. Now, I am fully aware that my music tracker is not very advanced. It's possibly not very user-friendly. It is enough for me at this stage, so that is why it is at that stage. The player itself and things, the format is very crude, but it's for the reason that I needed to be able to port this to a huge number of systems. I've ported it to the Z80, 6502, 68000. I've ported the music, the Chibi Sound Pro sound driver to basically every system I cover in my tutorials on those systems, and I might port it to the player to the 8086 and the 6809 and things later on. I'm still considering that because, as I said before, I can't make tutorials on this stuff. It might take me a week or 2 to port the player. I might be able to make 2 tutorials out of that, and the economics of it doesn't work. So once again, if you're interested in this, you want to see more of it, please consider backing me on Patreon so I can justify doing this. I'm not a musician. It's not a hobby of mine. I'm doing this because I'm hoping there's demand for it. Anyway, I hope you've enjoyed what you've seen today. Thanks for watching, and goodbye.